Welcome. Let us see the difference between uniform acceleration and variable acceleration. In uniform acceleration, the rate of change of velocity is constant. That is, the change of velocity with respect to time is constant. Whereas in case of variable acceleration, the rate of change of velocity is not constant. That is, the change of velocity with respect to time is not constant. Let us visualize it. First, let us take uniform acceleration. Just imagine a particle is here at time equal to 0 second, having a velocity of 0 meters per second. In the time 1 second, the particle acquires a velocity of 2 meters per second. And the time is 2 seconds, the particle acquires a velocity of 4 meters per second. And in 3 seconds, the velocity goes to 6 meters per second. And finally, in the 4th second, the velocity goes to 8 meters per second. Let's calculate the acceleration between the first two points. We know acceleration can be defined like this: the change in velocity to the change in time. And the final velocity is 2 meters per second, and the initial velocity is 0 meters per second. Hence, I am writing 2 minus 0 in the numerator part. And coming to the time, the final time is 1 second and the initial time is 0. Hence, I am writing 1 minus 0 in the denominator. On simplification, we get acceleration to be as 2 meters per second square. How we get meters per second square as unit means? Let's have a brief view. In the acceleration definition, in the numerator part, we have velocity, that is meters per second. In denominator, we have the time, that is second. And on simplification, we have meters in numerator, and denominator we have 2 seconds. On further simplification, we get meters per second square. This is how the acceleration is having the unit meters per second square. Let's move on to the calculation of acceleration for the next 2 points. We get acceleration to be 2 meters per second square. And the acceleration between the next 2 points gives us an answer like this. That is A equal to 2 meters per second square. And between the last 2 points, also we get the acceleration to be 2 meters per second square. As a whole, we can see that between any 2 points, the acceleration is 2 meters per second square. Again, we have 2 meters per second square. Here, the acceleration remains constant. Hence, such type of motion can be called as uniformly accelerated motion. Let us see a practical example for this case. Acceleration due to gravity for Earth. Just imagine you are dropping a ball from a mountain or from a top of a tower. Initially, let that particle has a velocity of 0 meters per second. In 1 second, it acquires a velocity of 9.81 meters per second. In the next second, it acquires a velocity of 19.62. In the next second, 29.43. In the next second, the velocity goes to 39.24, and it goes on like this. Let's calculate the acceleration. The acceleration between the first 2 points, that is 9.81 minus 0, the whole divided by 1 second, will give you the acceleration to be as 9.81 meters per second square. Similarly for the next 2 points, next 2 point will give you the same answers. This shows that the acceleration due to gravity for the Earth is constant, that is uniformly accelerated motion. This also gives us an understanding like this. Whenever an object is approaching the Earth, the velocity increases like this at an acceleration of 9.81 meters per second square. Okay, with this understanding, let's move to the variable acceleration. Just consider a particle to be in this place in time 0 second, having a velocity of 0 meters per second. In 1 second, it acquires a velocity of 2 meters per second. In 2 seconds, the velocity increases and goes to 8 meters per second. In the 3rd second, the velocity actually decreases from 8 to 4. And in the 4th second, the velocity increases from 4 to 6. Let's calculate the acceleration now. The acceleration between the first 2 points gives us the answer like this: 2 meters per second square. Between the second and third point, we have the acceleration as 6 meters per second square. Between third and fourth point, we have minus 4 meters per second square. Why we have the negative sign here means because the velocity decreases here. Actually, instead of saying as acceleration, we should say here retardation happens. So 4 minus 8 gives us a negative value here. Hence, here we have the answer in negative sign. And finally, between the last two points, we have the acceleration as 2 meters per second square. A general view says like this: the acceleration is not constant throughout. Here we have 2, 6, minus 4, 2. Hence here, we can call this type of motion to be as variable acceleration type of motion. Okay. With this understanding, I end this video.